Alright, so I'll be talking today about woodland habitats in the Mount Lofty Ranges. And particularly my collaborators and I are trying to focus in on if we are implementing prescribed burns in woodlands like this, what that might be doing to our native birds. So I'm sure we're all very familiar with the Mount Lofty Ranges, but it's probably worth noting a few things. So essentially what we have here is the ranges are an island woodland habitat. They don't contain any endemic species, but they do contain endemic subspecies. So one example is our threatened subspecies of the chestnut-rumped heath wren. And 90% of the woodland has been cleared, as we've heard, primarily for agriculture. And we still have a lot of urban development along the fringes of Adelaide. So what we're left with is this very fragmented woodland system. You can see these dark green patches here, and we are burning these habitats to try and reduce the fuel load. Now, I think a reasonably common paradigm in fire management is that pyro-diversity begets biodiversity. So essentially this means that if we burn to maintain a range of time since last fire classes, then we shouldn't be compromising our biodiversity or conservation goals too much. Okay, so if that's true, then maybe we can freely implement prescribed burning targets, such as burning woodlands once every 20 years, and everything is going to be okay. But what I want to ask today is whether or not that paradigm really holds in a very modified landscape like this. And the data we'll be using to look at this is from the Mount Lofty Ranges Woodland Bird Monitoring Program, and this is a long-term project, collaborative project run by the Adelaide and Mount Lofty Ranges NRM Board, the Nature Conservation Society of South Australia, involves University of Queensland and others. Okay. So essentially, this program since 2001 has monitored and counted birds at 151 core 2 hectare sites. There are 3 surveys conducted at each site in each year, and for the purpose of today we've retained 60 of the counted species, which actually account for more than 99% of all the birds counted over the period, and these are all terrestrial non-migratory species. Okay? So for each of the sites we know the fire history, and we have sites that have never been burnt in recorded history, through to sites that were burnt immediately in the year preceding sampling. And for those burnt sites, we can actually plot out the number of burnt sites each year through time, and clearly see the increase in prescribed burning frequency here over the last decade, which is what's motivated our interest in all of this. Okay, so as you can see from these before and after shots, probably the most obvious effect of a prescribed burn is to remove the understory while leaving the canopy reasonably intact. So with this in mind, we were wanting to ask 3 questions. So how does fire affect, firstly, the total bird abundance, so just the number of birds at a site, alpha or site level diversity, and thirdly, the proportional abundance of each of these species. And the approach that we've taken is firstly to try and identify trends in these variables across the Mount Lofty Ranges, and then to look at the effects of fire after correcting for those. And the point of this is to try and look at, if we're increasing the frequency of prescribed burning, is that going to be reinforcing or counteracting the broader scale trends? Okay, so first up we'll have a look at some generalised additive models of bird abundance. So these models basically allow a flexible non-linear response curve if the data requires it, and you can fit random side effects in this case. And so the first result here is a substantial non-linear decline in bird abundance per site over time. So back in 2001 we've got an average of, or an estimate of above 35 birds per site. In 2014 we're down at around 20 birds per site. So after correcting for that nonlinear trend, we can look at a partial response plot for the effects of fire. Okay, here we're conditioning on 2015 as the most recent sampling year. On the x-axis we've got unburnt sites, that's the point estimate here, and then for sites that are burnt, the relationship between abundance and time since last fire. Okay? So obviously these confidence intervals are reasonably wide, but if you want to contrast with unburnt sites and compare the lower bound here to the upper bound of the burnt sites, we can say that all sites burnt within the last 20 years have a lower abundance than these unburnt sites. And we can also estimate for sites burnt in the year immediately preceding sampling a 17% decline in abundance relative to the unburnt sites. Okay? So, as I said, we were interested in looking at the effect of fire on both diversity and the proportional abundance of different species. And it turns out there's a class of model called a multinomial regression model which can handle both of those things simultaneously. So essentially what this is doing is modelling the proportional abundance of different species jointly, and then from that we can get estimates of Shannon diversity as well. And here I've also done a cross-validation to choose an appropriate truncation for time since last fire, which was 20 years. So essentially truncating time since last fire at 20 years didn't reduce the predictive power of the models. In fact, it increased it. And the reason for that is we don't have many sites burnt past 20 years, and there's lots of species with not much data. Okay? So these models have a truncation of 20 years for time since last fire. These plots show diversity estimates, firstly over time, and you can see there's no change there. And similarly, there's no effect of fire or burning in the last 20 years on diversity. So does this mean that our burning isn't affecting bird assemblages? Not really. This is a univariate measure. It can stay constant even when you have winners and losers amongst an assemblage. Okay, so we can drill down a little bit further and look at the species level responses. So this is an example for the scarlet robin. Scarlet robin, the proportional abundance of the scarlet robin has actually increased over time and is also higher in sites that were burnt more recently. Okay, so we've used this species level output to classify each species according to trends in proportional abundance, so decreasing or increasing, and the effects of burning within the last 20 years, so negative or positive. And I guess it's worth noting that I think there was that target put out a few years ago of burning everything essentially once in every 20 years. Okay, so if burning is removing the understory and creating more open habitats, we might expect it to favour the same sorts of birds that do well in the fragmented sort of urban fringe environments. And essentially, that's the sort of result we found. We found that for 2/3 of these species, so that's the species here shaded in red, for 2/3 of the species, the effect of recent burning is in the same direction as the broader regional trend. So we can break this up a little bit further. We've classified 37% of species as decreasing and also having a lower proportional abundance than recently burnt sites. These species are listed here, and the shading shows essentially the confidence that we have in placing those species in this group, and that's based on a spatial block bootstrapping of the data. So we can focus in on some species that we confidently put in this group, and the first thing you'll note is they're all small birds. Okay, we've got 3 honeyeaters, 2 wrens, and the silver eye. And the scrub wren, the fairy wren, and the crescent honeyeater are all species that are typically associated with a complex understory habitat. We classified 30% of species as increasing and having a higher proportional abundance in recently burnt sites. These are listed here. You can see there's a bit more red. Okay, so there's high confidence for more of these species for putting them in this group. And that's essentially because this group contains a lot of fairly common species that we have a lot of comprehensive data for. So if we look again at the ones that we confidently put in this group, we have only 2 small birds, the white-browed babbler and the scarlet robin. And this might seem a bit counterintuitive, but these are both birds that have, or that preferentially forage on the ground and might benefit from more open habitats. We have the common bronzewing, which is a large granivore that likes to feed on the ground, and the red wattlebird, which is large and aggressive nectarivore / insectivore, which is common in our urban fringes. The Adelaide rosetta and the sulphur-crested cockatoo, both granivores that feed on the ground. And last but not least, we sort of confidently put 4 large carnivorous birds in this group. All of these feed on the ground. The magpie, the currawong and the raven are also very aggressive birds which could potentially affect the survival and fecundity of other species. So what does that mean? To sum up, we found that burning reduces bird abundance with a 70% lower abundance at sites burnt in the preceding year relative to sites that have never been burnt in recorded history. Burning seems to be favouring larger, generalist, aggressive birds, and particularly those that forage on the ground. Many of those are actually already increasing across the region, and burning seems to disadvantage small specialist birds and also those that rely on a complex understory. And unfortunately, it's those small birds that are in decline across the region as well. So, does biodiversity beget biodiversity? Well, this perhaps was the case before we cleared 90% of the vegetation, but I'd suggest that now it's not the case. Okay, so if we have 10% of the woodlands left and we burn those, we're creating more open, structurally simple habitats which are likely to favour the same birds that do well on our urban fringes. So I think this probably suggests that long unburnt woodlands are important for conserving the full suite of species. And my question, I guess, for any interested listeners here today is whether our prescribed burning regimes can actually accommodate the retention of these long unburnt areas. Can I just finish by acknowledging the huge number of people and organisations that have contributed to the long-term monitoring program. Thanks.